Hopefully, I can make it through this presentation without coughing or hacking up a lung. This is Miss Krupstat, and we're going to cover three sections today: 10.1, 10.2, and 5.1. But you'll notice a lot of similarities between the three sections as well as things that we already know. So the first function, a new function we're going to learn, is the square root function. And we've been working with square roots last unit, so you should be fairly familiar with some of the properties. So let's take a look. Here are some questions. Can you evaluate the following? So, for example, the square root of 100. Well, the square root of 100 is 10 because I'm not going to be able to write that every time. 10 times 10 equals 100. It has a perfect square root. Okay, now the negative square root of 25. Well, the square root of 25 is 5, and then we just make it negative. So that works out fine. And the square root of 25 is 5 because 5 times 5 is 25. Now, we've talked about this next one in class. This does not exist because in order to make a negative 9, I would need to multiply a negative 3 and a positive 3. So this does not have a square root. I cannot take square roots of negatives. And then this last one, not quite sure why we do this, but we could add those together, and that gives us 4 because 4 times 4 equals 16. All right, so you remember some stuff about square roots, I'm assuming. What we're going to do today is we're actually going to graph a square root function. So we're going to create a table of values, and we're going to plot the points, and you're going to see what this picture or this graph kind of looks like. Now, when we create a table of values for a square root, we want to think about what inputs are easy to evaluate. And also, you guys, this is in your notes. So if you wanted to copy this down, you could, but I'll show it on another screen as well. Now, by inputs, I mean, what numbers can we plug in for x? Well, we're definitely not going to want to plug in any negative numbers because we already know we can't take the square root of a negative number. So let's start with the smallest number we could take the square root of, which is 0. So we would be evaluating the square root of 0, which is 0. So that's our very first point that can go on the graph. Now let's think about the next smallest number that we could take the square root of. Well, we can take the square root of 1. It's not very interesting, but the square root of 1 is 1 because 1 times 1 is 1. So our next point is 1, 1. Now, I could put 2 here if I wanted to, but we know that 2 doesn't have a nice square root. It would give us a decimal, so let's try to avoid decimals today. Also, the square root of 3 would give us a decimal, so the next nice square root would be 4. The square root of 4 is 2. So there's our next point. And then our last point would be the next nice square root that we would have, which would be 3 times 3, or 9. So if I plug in a 9, I get the square root of that is 3. So that is our last of these 4 points. Now, this graph is fairly interesting because it does not go below this point 0, 0. This is what we call the vertex. So the vertex, just like in a parabola, it is the minimum point, the smallest, lowest point that it could possibly be. And it doesn't go past that because we can't take square roots of negative numbers. So this is always going to shoot off in one direction every single time that we graph it. And when we graph it in class, we're going to require you to have 2 points. So I'll show you what those look like in a second. The minimum point here, sorry, is 0, 0. All right. Okay, so the square root function. If you didn't copy this down already, you should copy this down in your notes, what we literally just did, which is that the square root function is f of x, or y, is equal to the square root of x. We have this nice little table of 4 values, and we create this. It's essentially half of a parabola just facing the other direction. Now, I wanted to talk about those 2 points that we're going to require you to graph every time. So those first 2 points, 0, 0 and 1, 1, are going to be required. Now, we are going to start moving these around. So if you remember our rules for moving functions, moving graphs, we have the exact same rules that we have had before. So when we add or subtract a number underneath the square root, that's going to move our graph right or left, and it's always going to be the opposite of what you think. Then if we have a number on the outside of the square root, that's going to translate our graph or move our graph up or down, and it's going to move it based on it being positive or negative. You'll notice we have an a value in front We're going to keep that a value as 1 as we're learning these functions, but that a value would do the exact same thing, and we'll talk about that in a later section. So if you need to, pause the video and copy that down. So here's an example of what this would look like. So our normal square root function, normal, would be at 0, 0, and 1, 1. And again, we're going to require you to plot 2 points. So if you just drew a sketch of that, that's what that looked like. But now I don't want to do that graph. I want to do a graph that has been moved. This graph has a -4 underneath the square root and has a +3 on the end of the square root. That -4 moves our graph right 4, and the +3 moves our graph up 3. So what I'm going to do is I am just going to take both of these points and I'm going to move them right 1, 2, 3, 4, and up 1, 2, 3 to get a new point. And then I'm going to take that 1, 1 and move it 1, 2, 3, 4, and up 1, 2, 3. So now I have a new square root function that has just been relocated. It's using the exact same translation rules we have learned in the past. Let's look at another one. This time I have x minus, or the square root of x minus 2. So again, here's my original. You don't have to draw the original every time. You just basically need to remember that it starts at 0, 0, okay? This minus 2 is on the inside, so that's going to move my graph right 2. And I don't have any numbers on the outside, so it's not going to move up or down at all. If you wanted to, you could even put a +0 there. So all I'm going to do is I'm going to shift my points to the right 2, and I have my new graph. All right, let's look at the cube root function. That's literally it for the square root function. The cube root function is very similar. That's why we pair them together, but we're going to have to talk a little bit about cube roots. So the first question here is, how is the square root of 64 different than the cube root of 64? Well, the square root of 64, I am looking for pairs, right? So as we know, there is a pair of 8s that multiply together to get me 64. So the square root of 64 is 8. Well, guess what we're looking for when we're looking for the cube root of 64? We are looking for triplets, okay? 3 of a kinds, trios. So I can't stop necessarily at 8 and 8. I would need to keep going to 2 and 4, and then 2 and 2, and then the same thing on this other side, 2 and 4, and then 2 and 2. So the cube root of 64 is the same thing as 2 times 2 times 2 times 2 times 2 times 2. Just like in square roots, if I have the set that I need, which here it's a set of 3, that set comes out of the cube root and becomes just a single of it. So the cube root of 64 is 4. So really, what we're saying is 4 times 4 times 4 is 64. So it has a perfect cube root. There's some other interesting things about cube roots as well. So let's look at these 3 down below. Cube root of 8. So let's think about what 3 numbers multiply to give us 8. Well, 8 is 2 times 2 times 2. So the cube root of 8 is 2. Next one, 27. This is another common one, but we have the negative on the outside. So it's 27 is 3 times 3 times 3. So the cube root of 27 is 3, but we would put the negative on the outside because it already had it there. Just like in the square root, basically. All right, now in this next one, though, it's super fun because now we have a little more options. -5 times -5 times -5 gives us negative 125. If this was a square root, we wouldn't be able to do it because there's not 2 numbers that multiply to a negative, but we can do it when there is a cube root. So now we are allowed to take cube roots of negative numbers, which makes the graph look a little bit more interesting. Okay, so here's what a cube root function looks like. We're going to create a table of values. If you want to copy this down in your notes while we do this, that is a great idea. Again, we're going to think about what inputs are easy to evaluate. So the one I'm going to put in the middle, kind of the center of all of it, is 0. The cube root of 0 is 0. The next one, as I count up, is going to be 1. The cube root of 1 is 1 because 1 times 1 times 1 gives us 1. Now, thinking on the opposite side of 1 or of the 0, we're going to look at the cube root of -1. And it is now possible to take the cube root of negatives. Guess what multiplies 3 times to give us -1? If you said -1, you were right. Okay, and then in the last one, we're not going to do 2 or 3 or 4 or 5, right? Because we want to pick an easy number to do. So what would be the number that would give us a cube root equal to 2? Well, 2 times 2 times 2 is 8. So the cube root of 8 is 2. And then on the reverse side, we're going to choose -8 and think about the cube root of -8 is -2. So you might be thinking, wow, this looks a lot like a parabola because there's a lot of mirroring going on, but they're not mirroring exactly the same. So -8, -2, -1, -1, 0, 0, +1, +1, and +8, +2. So this does not look like a U. It looks more like an S because it's not reflecting it exactly opposite. It's going diagonal from it. And that's what a cube root function looks like. So you can have it on both sides. If you were just to kind of cut off half of it, it sort of looks like a square root function, but it has two sides. Um, we call the important point in this the point of inflection. You know, inflection means it's switching directions. Okay, so the point of inflection, or is a point where it's kind of changing directions or changing momentum, is 0, 0. Okay, that important point. Okay, so I would like for you to copy this down in your cube root section, and the exact same rules apply as a square root and a parabola and an exponential function. All the functions we've studied is that number that is adding or subtracting on the inside moves our graph right or left, and the number adding or subtracting on the outside moves our graph up and down. Feel free to pause this video if you need to take a second to copy that down. Before we move on, I did want to make sure we will ask you to plot 3 points when we're doing a cube root function. And for those 3 points, we just pick the middle 3 points. It kind of looks like a diagonal when you were graphing it. All right, describe the translation and then graph the function with 3 points. All right, so we have a cube root function. This is going to be important to pay attention to. That a normal cube root function, if I was going to plot the 3 points, would start at 0, 0. We would have 1 point going up to 1, 1, and one going down to -1, -1. So this is what a regular old, our mother function would look like, if you will. Now, in our new one, we are going to move the graph left 2 and down 1. So I'm going to take every point. I'm going to start with my middle one, and I'm going to move it left 2 and down 1. Take this next point, left 2, down 1, and this one left 2, down 1. And you'll see it looks kind of like a diagonal once we graph it. So really, if you can plot that middle point, then you can just draw a diagonal from there. Then we start in the middle and curve it up, and then start in the middle and curve it back. Don't mind all those little wiggly lines. I don't know why that's happening. Okay, let's look at one more. Again, we have a cube root function. Our normal cube root function starts at 0, 0 and has this little diagonal right in the middle. But in our new one, we are going to just do this outside number. Since it's an outside number, that is going to move our graph up 1. So I'm going to take every point and move it up 1. So that whole little diagonal I created just shifts up. So we're going to start in the middle, curve it up, start in the middle, and curve it back. All right, now the next thing you're going to be asked to do is, given a graph or given an equation, can you determine what type of function it is, how it got translated, and the equation that goes with that? So when we look at this first example, since this is just shooting off in one direction, that makes it a square root function, just the definition of it. So you're going to need to know what these graphs look like and be familiar with their general shapes. So this is a square root function. Now we want to identify and say what the translation was in words. What they mean by that is this is the vertex, right? Well, typically the vertex would be at 0, 0. So how did we move to get the vertex over to this new point? Well, we had to move left 4 and down 1. Knowing those things helps us write the equation of this graph. I'm going to use f of x, but you could definitely use y. That would be fine. And I'm going to think about what number would need to go in the inside that would move this graph left 4. Well, it would be a plus 4. And then in order to move it down 1, we would need a minus 1. Hopefully that makes somewhat sense. Again, you can always review and rewind if you need to. This next one, try this. I'll just walk through it with you just to make sure. We have the cube root of x minus 2 minus 3. Now, as a reminder, because it is a cube root function, we are going to have 3 points. So this is a cube root because of that little 3 in the elbow. We have a minus 2 on the inside, which moves our graph right 2. And we have a minus 3 on the outside, which moves our graph down 3. So normally our graph would be at 0, 0, but we're going to go right 2 and down 3. And that is going to be the new center of our cube root function. In order to graph the rest of it, I just need to make a diagonal, and then I'm going to connect the points by curving them slightly in each direction. All right, that is it for the cube root functions. Now you could definitely go back to page 10 and work on those practice problems, but you also have, you also have a 10-1, 10-2 worksheet that you will be getting from the sub in order to help you practice. I hope that went okay. Have a great day.